That's kind of nice. All right, so we're going to wrap up our FRQ grading of FRQ number 2. I did extend the due date. You could have submitted it late anyway, but I did extend the due date for the quiz yesterday where you got to enter your scores, your 2 scores. So that's technically due tonight now, so please get that done before tonight. Again, if you get a 1 or a 2 or a 5 or a 7, it doesn't matter what you get, your actual score on these. You'll get a completion grade as long as you submit your score, so I know you did it. Total out of 15. Okay, so we left off on number E, right? Okay. So, E says, we're talking about the rover. Determine the maximum distance the rover can travel on a horizontal Martian surface using its stored energy. Stored energy, you can think of as the ability for it to do work. Let me actually... Sorry, I forgot that. So think of the energy stored as the amount of work that the motor can actually do in getting the rover to move. And so if you think of it that way, then the stored energy is just the work that's going to be done by the rover's motor. And so the scoring guidelines, there's 2 different ways that we can kind of look at this. You can relate the maximum distance. Yeah. You can relate there's 2 ways of going about it, because we know the power output, we know the work, i.e. the energy stored, and we know we're looking for the distance, right? Yeah, we're looking for the distance. So we got a couple ways of going about this. We can use the power equation. And again, think of the work as the amount of energy that's stored in the battery that could potentially be used to get the object to move. This does give us another an unknown, t, right? And so there's 2 ways of going about doing this. We can say, all right, we can use constant velocity kinematics, which says that distance is simply velocity times time, right? Or velocity is distance over time. And so that gives me 2 equations for t. So we can just kind of solve this for t. T would just be the work divided by the power. And then I can substitute work divided by power in for the time there. So the distance that it will be able to travel is the velocity times the work divided by the power. So that's one way of doing it. Another way of doing it is still taking the power equation, but remember that power can be written as force times velocity. That's something to remember. Why can it be written as force times velocity? Well, power is work divided by time. Work is force times displacement over time if the force and the displacement are parallel. Displacement over time is velocity. So it's just force times velocity. Usually it's referred to as instantaneous power, right? You multiply the force that's being delivered by the motor times the velocity of the object at that particular instant. That gives you your instantaneous power output. Okay. So we can use that equation. Power is force times velocity. And then work is just force times distance. And then so we can solve this for, because we don't know the force, right? Yeah. So we can solve this for the force, this one for the force. That's going to be power divided by velocity. So here the work will be the power divided by the velocity times the displacement. Doing your math here, multiply both sides by the reciprocal v over p, and we get the same result that we had here. Essentially, velocity times work divided by power. So you get the same equation. Either way. There's 2 ways of going about it. And essentially it breaks down to this. They word it kind of differently. I probably wouldn't have if I had done this. For a correct formula for power, if you did it the first way with the power equation and kinematics, for the correct formula for power, you got a point. For a correct formula for distance, you got a point. Again, that's constant velocity kinematics. And then to actually calculate the answer, you got to show a little work and then get the 362 meters approximately. That gets you the 3rd point. Okay. If you did it the alternate way, they did it kind of, they did it a little weird. You end up doing the same thing, but for correct formulas for work and power, those 2 equations, you got 1 point. combining those to get the same equation that you got up here, but didn't get an extra point for, you got a point. And then for a correct calculation, you got the third point. E and F look complicated, or they sound complicated when you read them, but mathematically they're not that complicated. You just got to kind of dig into it a little bit. But the equations are real simple. Any questions about that one? All right, part F. Suppose that 0.01% of the power for driving is expended against atmospheric drag as the rover travels on the Martian surface. Calculate the magnitude of the drag force. Again, sounds pretty complicated. Sounds pretty complicated here. But we know we're dealing with power because it's asking, 0.01% of the power is being used to fight the drag force. And so we want to relate power and force. Well, we have an equation that does that. Power is force times velocity, as we just talked about. And we're looking for that force, so we just divide both sides by the velocity, so it's going to be power divided by velocity. However, it's not the 10 watts of total power that the engine can produce. It's 0.01% of that. And so we got to, the power is going to be 0.010001 times the 10 watts divided by the speed, which is that 6.7 times 10 to the negative third. So that's it. That's it. So for the correct formula, power equals force times velocity, you got a point. For substituting the correct percentage, right? It's not just 10 watts divided by velocity. That's not what we're talking about here. You got to multiply by 0.0001 times that 10 watts, because that's the fraction of the total power being used to fight air resistance. And then you just divide that by the velocity. So for that substitution with the correct percentage, and then for the correct calculation, it should be 0.15 newtons. Note it says 0.149 and 0.1 were acceptable. Right, so there's a range there. Notice that's 2 sig figs, 3 sig figs, 1 sig fig. You're not going to get points off for not using the correct number of sig figs. I'd recommend not putting like a 15-digit answer. Limit it to 2 or 3, and you should be good. Cool beans? So 3 points for that one. So go ahead and total those up for that second FRQ. Should be 15 total. And then again, enter that in the assignment from yesterday. Technically, it's not due now until tonight. All right, one thing I want to point out, we are going to test tomorrow. We're going to have a timed test tomorrow. Okay, you're going to have a time limit. You're going to start it in class if you're in class. If you're at home, you can start it whenever tomorrow, but you will have a time limit. It will allow you to continue working after the time limit is up, because I have students that they get a little extra time. But you want to stop. You want to stop, because I'm going to know if you took longer, and I'm going to have to deduct points for that. Okay, because we're halfway done now. We're getting to the point where you need to start worrying about the time it's taking to solve these questions. So what I did, I took the amount of time that, based on the AP exam itself, that you're expected to take on each MCQ and each FRQ, and I've written the test accordingly, giving you a little more cushion than you will in the actual AP exam, because we're not quite at AP exam readiness yet, but we need to start getting there. So you will have it will be a timed exam, so you're going to have to go kind of quick, like a normal AP exam. So you will have a time limit. I do want you to enter your answers if you can on AP Classroom. I'm going to try that out. Some students, especially students with Chromebooks, have trouble doing that for some reason, and so I will have a Canvas page where you can enter your FRQ solutions on the Canvas page if you can't get it done on the AP Classroom. Okay. I think that's all. One other thing. Make sure you bring your formula sheet. If you don't have one, if you've lost it, because I gave you one years ago, but if you lost it, just Google AP Physics 1 formula sheet, and you will be the first thing that pops up. Something I'll point out, there might be a multiple choice answer that you'll have to use the cosine of a certain angle or the sine of a certain angle. And you won't see, like, what you'll need to do is use the table on the back of this, unless you know your unit circle because you're in pre-cal or calculus. But the values of trigonometric functions for common angles are on the back of your formula sheet. So make sure, and they give you fractions, like the sine of 30 degrees is 1/2. And so any equation that you have that has the sine of 30, you can replace that with 1/2. You will need to do that on the test tomorrow. So keep that in mind. Have your formula sheet with you. I would have a class set, but I'm not allowed to take papers back from you guys, so I'm not going to keep printing a full class set of formula sheets every test. Okay? All right, rest of the period, please work on the test review that you picked up on the way in. I did make an answer key last period. I will have that posted on the Canvas module, today's Canvas module within, I'll do it this period.